Welcome to the next arithmetic tutor training video. This one's all about scientific notation. However, before we talk about that, we have to do a review of some exponents. So let's start with just 10. That's going to be helpful with scientific notation. If we look first at the positives, if I try to get from one 10 power to the next, 10 to the first power, of course, is 10. To get to the next one, I'm going to multiply by 10. 10 times 10 is 100. Every time I move to the right, I multiply by 10 and add a 0 at the end, because our number system is based off of 10. So each time I add a 0 and I multiply by 10. However, if I was going to go backwards from 10 to the 4th to 10 to the 3rd, I would divide by 10 or take away one of the zeros. Each time I do that, it gets smaller and smaller until I get to 10 to the 0 power, which I would then divide 10 to the first power by 10. 10 divided by 10, of course, is 1. Any number to the 0 power is 1, even 10, any number that'll be true for. But if I keep going, I then have 1 divided by 10, 1/10, or 0.1. Keep going, 1/100th, 0.01. Oops, that's a 1. So as I go to the left with the negative exponents, I get smaller and smaller and smaller, and less than 1. So negative exponents mean there is a small number, fraction, and positive exponents mean we're talking about a pretty big number, bigger than 1. So for scientific notation, this is actually really helpful. If we have a really big number, like 245,100, we want to write it as a big number, we just see how many place values it has. Because remember, our number system is based on 10. So we write it as 2.451 times 10 to the 5th, because there are 1, 2, 3, 4, 5 decimal places until we can get to 1 digit in front of the decimal. That's a rule for scientific notation. The first number, so the non-10 part of the expression, is between 1 and 10. You can also think about it as there is 1 digit in front of the decimal. That is not a 0. You'll hear this word more later in your education principles videos. Convention is just something that we all decided. There's not really a mathematical reason for it. We decided we have to stop somewhere, so we might as well stop when the number is between 1 and 10. For a really small number, like 0.00031, we're going to express that, because it's small, with negative exponents. So we're going to go 1, 2, 3, 4 spots until there's a 3 in front of the decimal, and that would be 3.1 times 10 to the negative 4th. That's all about scientific notation, but we can also do operations with scientific notation. Of course, we could change the numbers back into regular decimal notation, but sometimes that's not very efficient. The numbers are really large. So let's look first at addition and subtraction. You may remember from our fraction video that addition and subtraction require like things. That is always true, no matter what you're adding and subtracting. We have to have like things. So if I'm looking at this first addition problem here, 3.8 times 10 to the 5th plus 1.1 times 10 to the 5th, those are like things, right? They are both 10 to the 5th. So I can just add those, no problem. 3.8 plus a 1.1, I get 4.9, and I keep my times 10 to the 5th. However, you've probably already noticed, on the second one, we do not have like things. One is a 10 to the 11th place, and one is a 10 to the 12th. If I wrote those all out in regular notation, they would end at different spots, because the 10 to the 12th would be a bigger number. Let's go ahead and write this vertically. Help us see that a little bit. What I can do, though, just like with fractions, I can make them be like things. So this would be really great if either the top one was 10 to the 12th or the bottom one was 10 to the 11th, that would be awesome. But let's say we want to try to make the top one 10 to the 12th. If I am going to add a 1 here, then I want this whole number on top to still represent the same amount if I were to write it out in decimal notation. So if I'm adding 1 to my exponent, that means I need to take away a place value to have it still be the same number. Kind of like if I'm going to take one step forward, I'm going to need to take one step backward in order to still be at the same place. The second number would stay the same. It already has a 12. And so then I can add, because these will line up correctly. 4.3 plus 0.38 is 4.68. And I can keep my 10 to 12. So also, I just want to point out that I could have gone the other way. If I wanted to change the bottom number, it would have looked like this. If I change that to be smaller, instead of 12, make it 11. If I take away 1, I'm going to make this number bigger. It's going to be 43.0. I don't have to even write that part. So then I would add them together. Now they're the same. I have 46.8. The problem here is that that number is not in scientific notation because this is not between 1 and 10. So again, I'd fix it. I'd take away 1 decimal place, and so I would add 1 to my exponents. You see, I got the same answer no matter which one that I changed. So if you make the exponent bigger, you're going to need to make the number smaller, the non-10 number. If you make the non-10 number bigger, like we did here, the exponent gets smaller. Let's go ahead and write that process. And this is also true, of course, with subtraction. Let's go ahead and erase this since we already have the answer next to it. Erase. Same answer. Get the same exponent, just like we did with fractions. We're getting a common denominator. Here we're getting a common exponent by moving the decimal and changing the exponents. Then add or subtract, depending on the problem. And just like we had to do on that last part, you always want to make sure that it's actually in scientific notation when you're done. Alright, you may have remembered that with multiplication, luckily we do not require like things. The same thing is true with division. So you can just focus on the numbers that are not 10 first. So 3.7 times 5.1, let's go ahead and multiply those on this problem, and we get 18.87. And then we're just going to combine all of our 10s. So we have 3 10s and 4 10s. Add those together. You have 7 10s. Are we done? Nope. Sadly, this one is not in scientific notation. We got to fix it just like we did on that one problem a minute ago. We're going to move that back. So it's 1.887 times 10 to the, oh, we have to fix it. So we made the first number smaller. So we make the exponent bigger. So that's times 10 to the 8th. Alright, so we can deal with the non-10s and then add our exponents together. With subtraction, sorry, I gave it away. With division, we're going to do something similar. Deal first with the numbers that are not 10. So we'll divide those. We get 3.81. Okay, and then times that, we have 10, and instead of adding, because we're dividing, we're going to subtract those. So 22 minus 4 is 18. Here's our process. When you're multiplying and dividing, deal with the non-10s first. And then if you're multiplying, you're going to add the exponents on the 10. If you're dividing, you're going to subtract the exponents on the 10s. And I always check for that correct scientific notation. On our last problem, we were between 1 and 10, so we're good. And those are the operations of scientific notation. Go ahead and watch the next video on the order of operations.